Okay guys, we're working on the quadrilateral review. Remember only to do the circle questions. So that's going to be questions 1, 3, 6, 8, 9. Then the second page will be 14 and 15. And then 17B on the third page, 18 and 19. I'm going to try to do all of them, but it is going to be a little quick. Okay, so if you need to, please rewind, pause, do whatever you have to do so you can make sure you understand everything. I want to go over the entire packet, so make sure that you are listening and paying attention. But watch it as many times as you need to. Okay, this is tough stuff, but please have your pink sheet right next to you because I'm going to refer back to it in terms of the properties. The first one, find the value of each variable in the quadrilaterals. We're talking about quadrilaterals here. So if you look at the top of your pink sheet, it tells you the two main properties. What is a quadrilateral and what happens with the angles? Well, it tells us that the angles all have to add up to 360. So what I can do here is I can add up all 4 of those angles, because it's a quad, and set them equal to 360. Combine your like terms. 8 plus 7 is 15, plus 3 is 18, plus 4 is 22. X equals. Okay, so, well, it says that we have diagonals here, so let's start drawing on the diagonals. 5 is congruent to 5, and 7 is congruent to 7. Okay, so we have the diagonals bisect each other, which means it can be a parallelogram. But then we also have the fact that the diagonals create a 90-degree angle. Well, if you look at a rectangle, that says diagonals are congruent. We don't have that. But if you look at a rhombus, it says that the diagonals are perpendicular. They have a 90-degree angles there. So it's more specific than a parallelogram because the diagonals have a 90-degree angle, so it must be a rhombus. Okay, question 9. I set it up already by plotting the points. This is the one we have to go through the slopes and the distance formula to prove which type of quadrilateral it is. Okay, so the first thing we can do is we can find our slopes. Now remember, to find the slope, all we have to do is count the rise over run. You can absolutely use the slope formula if you'd like, but we can always just count rise over run. From P to Q, I'm going to start at P. I'm going to go up 2, and then the right 1, 2, 3, 4, 5. So up 2 fifths. From Q, I'm going to go down 5 to the right 2, so negative 5 over 2. From R, I'm going to go down 2 and then to the left 5. And then from S, I'm going to go up 5 and then to the left 2. So let's simplify all these. This simplifies to 2 fifths. This simplifies to negative 5 over 2. This one simplifies to a positive 2 fifths because a negative divided by a negative. And this simplifies to a negative 5 over 2. Okay, so remember, if slopes are congruent, that means they have parallel sides. And if slopes are opposite reciprocals, that means we have perpendicular. So let's take a look here. If you notice, 2 fifths and 2 fifths means that PQ is parallel to RS. PQ parallel to RS. And if you also notice, negative 5 over 2, negative 5 over 2. So that means PS is parallel to QR. Okay, so we have opposite sides parallel. Good. We can cut out kite, trapezoid, isosceles trapezoid. Now we're going down the parallelogram route. But let's see if we have 90-degree angles, because then we can figure out if it's a rectangle or rhombus. They have to be opposite reciprocals. So take a look at two sides that are next to each other. 2 fifths and negative 5 over 2. Well, opposite comes from the fact that one's positive and one's negative. Good. And then the reciprocal comes from the fact that if I take the fraction and flip the numerator and denominator, they have to be the same thing. So if I take 2 over 5 and I flip it, that's going to give me 5 over 2. So these are opposites because one's positive, one's negative, and they're reciprocals because 2 over 5 reciprocal is 5 over 2. So because of that, we have perpendicular, which means 90-degree angles. That means we now have the option of a rectangle or a square. Now the main difference is rectangle only has opposite sides congruent, whereas square has every side congruent. So there's two options here. Okay? You can look at the slopes and realize that they all have 2 over 5 or 5 over 2, meaning if you were to use Pythagorean theorem with a right triangle, they would all have the exact same hypotenuse, thus the same distance. Okay, but if you can't see that, then let's use the distance formula. Okay, so the distance is, I'm going to do my best to make this as quick as possible, but it's x minus x and y minus y quantity squared, and then add them up. So let's find the distance between P and Q. So P is negative 3 minus 2, because that's the x values of P and Q, and then 2 minus 4. Okay, square root, negative 5 squared. 2 minus 4 is negative 2 squared. Remember, we're talking about distance here. So everything's going to be positive after you square it. So that gives me 25, that's a 5, guys, and positive 4, which is the square root of 29. Okay, so the distance of P and Q is 29. Well, we know the opposite sides are going to be the same, so let's look at a side that's next to it. Well, a side that is next to PQ is going to be QR. Okay, so let's find the distance of QR and see if they're the same. If they're different, it's a rectangle. If they're the same, it's got to be a square. So Q is going to be 2 minus 4, because that's the x values, and then 4 minus a negative 1. Okay, let's keep simplifying here. 2 minus 4 is negative 2, and then whenever you subtract a negative, it turns positive, so we get 5 squared. That's going to give me 4 plus 25, which is equal to the square root of 29. Okay, well, if you notice, these are both the exact same thing. So that means that opposite sides are congruent from the slopes, and consecutive sides are perpendicular, which means 90-degree angles. Okay, and we just proved, whether it's through Pythagorean theorem using the slopes or through distance formula, that all sides are congruent. So if you want to put that congruent mark on all 4 sides, you absolutely can. This gives us an answer of a square. Okay, if you'd like another practice problem for that type of question, take on number 11. Number 13 we did as a class in your notebooks. If you want to take a look at that, how to use the coordinates with A and B. Remember, you could think of up A over B to calculate those slopes. Okay, but I want to take a look at 14. 3 of the 4 vertices of a rectangle are given. I already plotted those on here. Find the coordinates of the 4th vertex. Find the area and perimeter of the rectangle. Well, here's the deal. A rectangle has opposite sides parallel. So if I can count the slope from this side to this side, then it's got to be the same slope on the opposite side. So the slope right here is down 1, 2, 3, 4, and then the left 2. So down 4, left 2. If I follow that exact same slope, I'm going to go down 1, 2, 3, 4, and left 2, which is going to give me this coordinate 4, 0. And now we know we have the shape that it was asking for. Okay, it also should be the same slope for the other opposite side. So I'm going to go down 2 and to the right 1, 2, 3. Down 2 to the right 3. So there we go, we have a rectangle. But then it says find the area and perimeter of the rectangle. This is where it gets tricky. And the only way to find area and perimeter is if we know the distances. Okay, so you're going to have to plug in the distance formula here. So distances, now we know it's a rectangle, so opposite sides are congruent, so all we need is one of the base and one of the height. So I'm going to plug in 1 minus 3 squared plus 2 minus 6 squared, because I did x, y, x, y. So the distance is negative 2 squared, negative 4 squared. Distance is going to be positive 4 plus 16. So d equals the square root of 20, which is approximately 4.47. Okay, so we just found the distance of this side. So now we need to find the distance of the side next to it. So I'm going to do distance of 3 minus 6 squared, that's this xy and this xy, plus 6 minus 4 squared. That's going to give me negative 3 squared plus 2 squared. It's going to be 9 plus 4, square root of 13, which is approximately 3.61. So that means my base is 4.47, so area equals 4.47 times 3.61. And my perimeter, you add 2 of the 4.47s, and you add it to 2 of the 3.61s, or adding up all 4 sides. And remember, we know opposite sides are congruent, so that means only 2 of them. So 4.47 times 3.61 is approximately 16.14 units squared. And then for the perimeter, I have 2 of the 4.47 sides plus 2 of the 3.61 sides. That's going to give me approximately 16.6 units. Okay, we also have question 15. Not a parallelogram. Okay, so we have to use our properties of quadrilaterals because we are not given a parallelogram. So that means I need to add up all 4 angles equal to 360. So I have 5x minus 15 plus 3x minus 1 plus x minus 16 plus 4x plus 34 equals 360. Combine all your x's. 5 plus 3 is 8, plus 1 is 9, plus 4 is 13x. Then negative 15 minus 1 minus 16 plus 34 is positive 2. I added all these up. Equals 360. Subtract 2 from both sides. So 360 minus 2 is going to be 358. And then divide that by 13. And we get x equals 27.54. Okay, last page. Okay, take a look at number 7. Write a convincing proof that the opposite sides of a parallelogram are congruent. I labeled a few things on the picture, and I started with the first step because we all know how to start with the given. It's a parallelogram. Okay, and remember, once you find the parallelogram, you can use definitions of the parallelogram. Well, the first thing on our pink sheet that splits it up between a kite, a trapezoid, and a parallelogram is the number of parallel sides. And a parallelogram has opposite sides parallel. So that means I'm going to label my opposite sides parallel, which means I have, let me do this over here, I have AD is parallel to BC, and then I have AB is parallel to DC. These are the opposite sides, okay? Now that I do that, I can now use these alternate interior angles, but before I do that, I have to draw AC, the diagonal. Remember? Okay, so a line segment between any 2 points. Okay, step 4. Now that I've drawn, so now that we have our diagonals, we can now use these alternate interior angles, angle 1, 2, 3, and 4. Okay, so the ones that are alternate interior of each other are angles 1 is congruent to 2, angles 3 is congruent to 4. And we know that they are congruent because alternate interior angles are congruent. Okay, so if you go to your picture, you can now mark 1 is congruent to 2, and 4 is congruent to 3. Okay. So next, we drew the diagonal, so now let's use the diagonal. It is part of both of the triangles. So remember, if a side is part of both triangles, we can now say it's congruent to itself by the reflexive property. So if you go to your picture, you can mark a little congruent. We got our congruent angles. So now we have 3 parts, 2 pairs of angles and 1 pair of sides, which means that we can, prove triangle ADC is congruent to triangle CBA. Because 2 angles on one side, and that side is between the 2 angles, so we can use angle, side, angle. Last but not least, go back to what we're trying to prove. Opposite sides of a parallelogram are congruent. Well, if we know that the left triangle is congruent to the right side, then we also know that its sides are congruent to their corresponding sides, which means that AD is congruent to its opposite side, which is BC, and AB is congruent to its opposite side, which is DC. And the reason we can do that is by CPCTC. Okay, last one I'm going to do, question 18. Describe the transformation that maps ABCD onto A prime, B prime, C prime, D prime. So, it looks like there's no rotation going on because B is still the top right, C is still the bottom right, D is still the bottom left, and A is still the top left. So I guess it's just a slide, a translation. So I need to count how far does it go left or right before I can get to the other B. Well, it goes to the right 1, 2, 3, 4, 5, 6, 7. And then it goes down 1, 2, 3, 4, 5, 6, 7. So I need to write the rule. Okay, remember with the translation, you start with x comma y, and then you tell me what happened to x and what happened to y. Well, if it's going to the right, then we're adding 7 to it, and if it's going down, then we're subtracting 7 from the y value. And there you go. Okay. Okay, I know it's going to be tough. I know this is a longer video because we did a lot of proofs, but I hope if you take the time to study, you'll be able to get this stuff. Good job, guys.